Find the area of the shaded region. So looking at this region here, this is the first time that we've seen an area where it's not bounded below by the x-axis. So if you're not seeing that, what you can do to really observe this is think about some arbitrary x value here. If you draw just a slice or almost like a cross section of our two-dimensional region, you can see here that the curve is bounded above. So this is the upper bounding curve at the line y equals 4. And it's bounded below by the curve y is equal to 3 cosine of x plus 1. So when we have an area like this, we're going to use the following formula. So our area is going to be defined as the definite integral from a to b, and we're going to take the top curve, and then we'll subtract the bottom curve to attain that integrand, and we'll integrate this with respect to x. And so just relating this to what we already know, basically what we're doing is we're taking the area under the top curve. So what this means is that we're taking the area under the top curve and above the x-axis, and we're going to subtract the area under the bottom curve and above the x-axis. So you could do this as two separate integrals, and that's what gives you this full area. You could think about this as the integral, and here we can see our bounds are from 0 to pi over 4. And we can think about this as the area under the top curve and above the x-axis, so this would just be 4 dx minus the integral from 0, and excuse me, that bound, shame on me, our upper bound is pi by 2, not pi by 4. So that's the area under the top curve, so that's that full square. And we're subtracting the area underneath the curve here, which would be the integral from 0 to pi by 2 of 3 times cosine of x plus 1 dx. But we don't want to do two separate integrals here. We can combine this to one happy integral, and we can rewrite this as the integral from 0 to pi over 2 of the top curve, 4, minus the bottom curve, which is 3 cosine of x plus 1 dx. And so again, we don't typically write it out the longhand way like this. We can just immediately go and use this formula. But now you at least see where it comes from. And look at this, we've set ourselves up here and we're ready to go ahead and find the area. Again, this is giving us our total area. And so let's distribute this negative through to both pieces, and then we'll simplify. So we have the integral from 0 to pi over 2 of 4 minus 3 times cosine of x minus 1 dx. And we can combine our two constants. We have 4 and minus 3. So this leaves us with the integral from 0 to pi over 2 of 3 minus 3 times cosine of x dx. And look at that, we have a greatest common factor of 3, so let's pull it out. So we have 3 times the integral from 0 to pi over 2 of 1 minus cosine of x dx. And so this is a beautiful general antiderivative, and we're ready to integrate. So this will be 3 multiplied by x minus sine of x, and we're going to evaluate from 0 to pi over 2. So here we go. We have 3 multiplied by pi over 2 minus sine of pi over 2. And now plugging in the lower bound, we have 0 minus sine of 0. And we know that sine of pi by 2 will go to 1, and sine of 0 goes to 0. So this is equal to 3 multiplied by pi over 2 minus 1. And of course, getting that common denominator, we think about 1 as being 1 over 1. Multiply the numerator and denominator by 2. No fractions. So this will be 3 multiplied by pi minus 2 over 2. And that's our beautiful final answer. So therefore, the area of that shaded region is equal to 3 times pi minus 2, all divided by 2. And since this is area, we must include square units.